Hey everyone, let's see how we can solve this problem using binary search. Right, so we are given an array and every element in this array occurs twice except for one element, and we have to find that unique element. Alright, and given that all the duplicate elements are adjacent to each other, and we have an example here that is this particular array, and we can see all the repeating elements are adjacent to each other, and we have just one element that occurs just once, that is 19, and we have to return 19 as the output of this particular problem. Right, yeah, so how can we do this? What are the different approaches that we can use to solve this particular problem? So one thing that comes to my mind is maybe run a for loop and maybe put a counter for each element, and see if the count is just equal to 1, then return that particular element. Otherwise, if there is no such element, then return false. Alright, that is one approach. The second approach will be much easier, that is using the bit manipulation technique or the XOR technique in bit manipulation. Right, so what is the property of XOR? So if we XOR two elements which are equal, for example, if we do 3, that is XOR, right, or it is written as 3 XOR 3, we will return 0. And if the elements are same, then taking XOR between those two same elements will give us an output of 0, and 0 XOR any other element, maybe if it is 2, like 0 XOR 2 will return that other element, that is 2. Right, so what happens is, if we take the XOR up until this elements, for example, this will be 0, this will be 0, this will be 0, this will be 0. So it will be completely 0 till this element, these elements. This is 0, and it will be 0 from this to this. Right, and finally, if we take XOR between 0 and 19, it will return an output of 19, that is our desired output or the unique element from this array. Right, let's see how to write a code to find the unique element using the XOR property. Right, let me just clean this up real quick. Alright, so what we can do is maybe initialize the answer to 0 initially first, so answer equal to 0, and run a for loop. So for if we are using Python, maybe or let's take another language for I equal to 0, I less than or equal to n I plus plus, and let's take the XOR. So answer will be equal to answer XOR ARR of I. Then once the for loop is completed, then return answer, and it will return the final answer. But this has the time complexity of big of n, right? The question is, can we do better? And using binary search, if you can somehow find the answer, we can reduce this time complexity to log n. Right, let's see how it is done. If you look at the example we have, what kind of observations can be derived from this? If we just look at the first occurrence of each and every element that is repeating and check the index of that, for example, the first occurrence 3, the index is 0. The first occurrence of 1, index is 2. The first occurrence of 8, index is 4. The first occurrence of 10, index is 6. Right, so as of now, let us just consider the elements that comes before our unique element. Right, so the first occurrence of 3 is an even number. Right, first occurrence of 1 is an even number. The first occurrence of the next repeating element, that is 8, is an even number. First occurrence of 10 is an even number. Right, so what happens once we pass the unique element? To the right side of the unique element, the first occurrence index is an odd number. Right, first occurrence of 2 is an odd number. First occurrence of 4 is an odd number. Right, so it starts at node index and ends at even index. Here before the unique element, what happens is it starts at an even index and ends at an odd index, right? So let's figure out if we can use this property or this particular observation to find out our unique element that is in between or in the middle somewhere, right? So what we can do is we can just use the normal binary search. Let's fix L for this. That will be at the starting index here. This will be our L and or the leftmost, and this will be our right. This can be low or high also, L and H. I generally use L and R to understand left and right. Fine. And there is a mid value somewhere in between this. To find the mid value, we use mid equal to L plus R by 2, and we take the floor value of whatever we get for mid, right? So initially we set L equal to 0, and we set R equal to length of whatever the array name is. If it is length of ARR minus 1, right? That is the index 14. The length is 15 because we have 15 elements, and R is the index or 14, and L is the index of the first element, right? 0, and R is 14, right? So what can we do? So if the array is like this, and in the first step we calculate the mid value, and if the mid value is here, if the mid value is exactly equal to what we are searching for, then return that particular answer. And what are we searching for? We are searching for an element which is not equal to the element before that and not equal to the element after that, right? So what is the condition here? So what I can write is if ARR of mid is the index, right? Not equal to ARR of mid minus 1, right? And ARR of mid not equal to ARR of mid plus 1, then what should I do? Then I should just return ARR of mid or that particular element. In this case, ARR of mid will be 19, right? So this is case 1. Okay, so in the first step we'll calculate the mid, and if the mid value or the mid index is exactly the element that we're searching for, that is if it is not equal to the element that is previous to that element or to the element that is after the the unique element, we just return that particular answer. That is, we found the mid value we found the unique value, and this is it, right? Fine. The clever way next is to if it doesn't land on a number that we are actually aiming to, then just set the element to the first index, right? By that I mean, if for example if the mid value for some reason is landed on 10, all right, which is 0 plus 14 by 2 is 7. So if in the initial case it will be 7 only, index will be 7, and the element is 10, right? So what I'm telling is, if it lands on 7, just automatically switch to, if it lands on a number which is 10, just check the previous number. If it is 10 itself, then switch the index to the first occurrence of that number. For example, this, if ARR of mid, the number which we landed on, is equal to the number before that. What I'm trying to do is, if it is a second occurrence, I want it to be the first occurrence. That is all that I'm doing. If this is the case, the number that I landed on is exactly the previous number is if the number that I landed on is the second occurrence, then what I should do is I should automatically change the mid value, that the mid index, to mid minus 1, right? And why am I doing it? I'll tell you, right? One second. So if by any chance it landed on 6, it will check if the previous element is 10 or not. And if it is not 10, then we'll keep it as the first occurrence, which means it is the first occurrence of that number, right? So it will keep it as it is. And if it landed on 2 by any chance, this 2 by any chance, it will check if it is the first occurrence of 2. And if it is yes, the index will be 11 itself. Otherwise, the index will be 10, right? If that is the case, what we can do next is we can the next case is according to the property of the index. That is, so if we are landing on any of the numbers that comes to the left side of this particular unique element, and how do we understand that it lands on the left side? For that, the first occurrence will be always even number, right? The first occurrence of the index, that will be always an even number to the left side of the unique element, and to the right side of the unique element, the first occurrence of all the elements is an odd number. That is, the index is an odd number, right? So what we can do is, if if the numbers mid mod 2 equal to 0, which means if the index is an even number, what should we do? We should go to right, which means if the mid lands on anywhere here, we should go to the right to search for this particular element, right? So what do you mean by going to right? So if it landed somewhere in 10 is the index of 10 is an even number, so I should go and search left part. So R can be this itself, and I should shift my L value to somewhere here. If it landed here, I know that next element will be that 10 itself, because always mid will be on the first index, right? That is the condition that is given here. Mid will always be on the first index, that we have made sure about. So I don't want to shift L to the immediate next position of mid. I can shift mid to the position after that. So I need to put it here. So we landed on 10 actually, this 10 actually, and this was the value of mid. So L now is going to be at mid plus 2. Usually it is at mid plus 1 in other questions, but in this case it is going to be at mid plus 2. So if it landed on an even index, it will be automatically on the first occurrence of the number. So what we can do is L equal to mid plus 2. We can set as mid plus 2, and the next condition is when the index is odd. If it is not ARR of mid, it is the index that we are checking for. That is why we are using mid mod 2 not equal to 0. It means it is an odd index. Then we should go to left to search for it. Why so? Let's see. So by any chance, if it landed on 4, right, it will never land on 4, because always the mid will be resetted to the first occurrence of that number. So it will always, the mid will be at the first occurrence of that element. So the corresponding index of that first occurrence is an odd number, which means it lies to the right side of the unique element. So we need to go search all the elements that is to the right side of the element. In this case, what happens is we need to update the value of R. Initially R was at here, so initially R is at here, and we need to shift R to this position, that is R equal to mid minus 1. In this case, it is not mid minus 2, like L is shifted to mid plus 2, and so that mid should be, R should be shifted to mid minus 2. It is not the case, because mid is never the second element, it is always the first element, and we should just change to the next element. In this case, when we are going to write, there is always an element in front of it. That is why we are just updating it by 2. So in this case, R should be R equal to mid minus 1. That's it. That is our code, and this will run seamlessly. We have covered all the cases. This is the case 2, and this is case 3. If you want a dry run, let's see for this example itself. Yeah, so initially let's see L and R and mid, right? So initially L is here, sorry, okay, initially L equal to 0, that is L is here, and R is equal to 14, R is here. So what happens initially is L equal to 0, R equal to 14, mid equal to L plus R by 2. Okay, in this case mid equal to 14 by 2, that is 7. So ARR of 7 is equal to 10, right? Immediately once when we get the value 10, the first case that we check is if that element is equal to the right side element that to the right side of that element, or if it is equal to the element to the left side of it. That is, we run this particular code. Let's see if that is true. It checks whether it landed here. It checks if it is equal to this particular element, that is true, and it checks whether the element to the right side of it is true, and it is not true. So what? So this if statement is breaking, and we go to the next if statement. That is, if that element is equal to the previous element of the element immediately to the immediate left of that element. That is like this. If we landed on 7 and it is checking if the element previous to that is equal to that element or not. Yes, it is true. And what should we do? If it is 10, we should set the value of mid to mid minus 1. So what happens is we are setting it as true, so we are setting mid equal to mid minus 1, which is equal to 7 minus 1, which is equal to 6. So always the mid will be on the first occurrence of that element. What is the next case? If that is the case, once that is updated, it is going to the next if statement, and it checks if that mid value is even or not. And we got it, it is even, so we should set the L value to mid plus 2. So what, let's see, now mid is at 6, mid mod 2 is equal to 0, that is this even, so L equal to mid plus 2, that is 6 plus 2, which is equal to 8. So we shift L to the 8th index, that is here, 8, right? And R will be same as it is. So what happens is L will be 8 and R will be 14. So here 14 plus 8 by 2, that is 22 by 2, that is equal to 11. So ARR of 11, what is that element? ARR of 11 is 2. That is cool. Once it is 2, it checks if that element to the right side of 11 is 6, element to the left side is equal to this. Yeah, it is not equal to that. So what happens? It is so what happens is that if that is not the case, it goes to the next if statement, that is this one here. If that element is equal to the element before that, so we landed on 2 is equal to 6, nope. So what we do, so we don't have to update the value of mid value, which means mid is already at the first position, like it is always the first 2 is at the 11 is the first occurrence of 2 itself, so that is clear. So the second if statement is also not used here. So what we do is we go to check if the index is even or odd. So in this case, in this case the index is odd number, so we should go to the right side of it or search for the left side. So what happens is L will remain the same and R will be shifted here, that is mid minus 1, that is initially it was 11, now it will be 10, so it will be 8 and 10. 8 plus 10 by 2 is 16, 18 by 2, which is 9, and the loop continues until it reaches 19, and it checks for the element if it is 19 is same as the next element, and if 19 is same as the other element, and that is no, that is not the case. So the first case will work, that is this, and it will return ARR of mid, that is 19. And that is how we search for the unique element inside this particular array using binary search. And the whole process might look complex, but in every iteration, I mean in every case, we are reducing the search elements by 2 if there are n elements, using n by 2 and n by 2 here. In the next case it becomes n by 4, in the next case it becomes n by 16, and in that particular case what happens is at a particular point n by 2 raised to k will be equal to 1, so which means 2 raised to k equal to n, which means k equal to log n, and that is the desired time complexity that we need, which is less than n, and that is how binary search is efficient over normal search. So that's it for today. Stay tuned for more questions like this. So and if you like this video, don't forget to like and subscribe. So yeah, bye bye.